All right, everybody. Here we are starting to practice our Lewis dot structures. So this is a big concept. It will come back again and again, but that means you'll get a lot of practice with it. So we're going to start with something simple like F2. Now, when we have a molecule, which remember is composed of elements that are all nonmetals, we don't know its structure. And so we have to figure out the structure through another means. And that means is going to be drawing a Lewis dot structure. The first step to a good Lewis dot structure is always calculating the total number of valence electrons you have represented in the atoms present in your compound. How do we know how many valence electrons an atom or an element has? The group on the periodic table, or the column that it is in the periodic table. So fluorine, because of the column that it is in, is going to have 7 valence electrons. You will notice that in this molecule we have 2 fluorine atoms. So 7 times 2, we have a total of 14 valence electrons that we have to draw. The next thing I'm going to do is I'm going to choose which atom to put in the center of my structure. But if we look, we only have 2 atoms. This is a diatomic molecule. So we skip that step because nothing goes in the middle. From here, I draw a skeleton structure. I know that my fluorine atoms have to, at minimum, be bonded to each other at least one time. And so I draw a straight line to represent a shared pair of electrons between my atoms. And so right now in my bond, I have drawn 2 electrons. From here, I have to fulfill what's called the octet rule. The octet rule states that every atom is stable with 8 electrons around it. Hydrogen is the notable exception. It is stable with 2 electrons around it. And so I fill what we call lone pairs, or pairs of electrons that do not bond, are not involved in bonding, to fulfill my octet rule until I get to this magic number 14 for this molecule. So here I've got 2 already, and now I'm just going to start counting to fill my octet. Here's 4 electrons, 6 electrons, 8 electrons, 10 electrons, 12 electrons, 14 electrons. Now, if I look, this fluorine has 2, 4, 6, 8 electrons around it. So it fulfills the octet rule. Then this fluorine has 2, 4, 6, 8 electrons around it. It also fills the octet rule. And then if I count, I have drawn 2, 4, 6, 8, 10, 12, 14 total electrons. So this is my correct Lewis structure for F2. Now we're going to try a different one. Here is H2O. As always, we start with our valence electrons. Hydrogen has 1 valence electron. We have 2 of them, so that's 2 valence electrons. Oxygen has 6 valence electrons, and we have 1 of them. 2 plus 6 gives me 8 valence electrons that I have to draw in my structure. Now I say I have to pick one of these atoms to go in the middle. Normally, I pick the least electronegative atom to go in the middle. However, hydrogen, because it is only stable with 2 electrons, will never, ever, ever go in the middle of a Lewis structure. So even though oxygen is more electronegative, it has to go in the middle. Then I build my skeleton structure. I know this oxygen is going to be at minimum bonded to 2 hydrogens. And now I can start filling lone pairs, typically outside in, to get to a full octet. But if you look, both of these hydrogens already have 2 electrons around them, which means they're stable, they're good. And so now all I have to do is fill the octet in my oxygen. So I've already drawn 2 electrons and 4 electrons total from the bonds in my skeleton structure, and now I'm going to draw 6 for a lone pair and 8 for another lone pair. This gives me a full octet around my oxygen, stable 2 electrons each around my hydrogens, with 8 total electrons in my structure. This is the correct Lewis structure for H2O. Now let's try another one. Let's try H2. This one should be pretty straightforward. Hydrogen has 1 valence electron. I've got 2 of them, so whatever I draw needs to have 2 valence electrons. Lucky for us, hydrogen is stable with 2 electrons around it. Now this is diatomic, 2 atoms, which means I don't have to pick what goes in the middle. All I'm going to do is draw a hydrogen, and I know at minimum they're bonded somehow. But then if I check, in my bond, I have drawn 2 electrons, so I can't draw anything else. But both hydrogens are already stable with 2 electrons around it. So H2 is a very straightforward Lewis structure. Now let's try this one. Let's try CH4. As always, we start with our valence electrons. Carbon has 4 valence electrons, hydrogen has 1, times 4 hydrogens is going to give me 4 plus 4, which is 8 total valence electrons. Now I pick which one goes in the middle. The least electronegative goes in the middle, but that would be hydrogen, and hydrogen can never go in the middle. So my carbon has to go in the middle, and I'm going to draw my skeleton structure of hydrogens around it. Now I count. In this skeleton structure, I have drawn 2, 4, 6, 8 total electrons already. So I can't draw any more lone pairs. I'm stuck at this. But if I look, each hydrogen has 2 electrons around it, which is stable, and this carbon in the middle has 8 electrons around it, which is also stable. So this is the correct Lewis structure for CH4. All right, now this last one is a little out of the ordinary, but as always, we're going to start with our valence electrons. Carbon has 4, hydrogen has 1, we have 2 of each, so that's 4 plus 4, which is 8, plus 1, which is going to give us a total of 10 valence electrons. Now the reason this one is a little bit out of the ordinary is now we're going to pick what goes in the middle, but carbon can bond to itself, and then we're going to sandwich the hydrogens on either side. And so this is going to be our skeleton structure. Now already from my 3 bonds, I have drawn 6 total valence electrons. So now I fill octets outside in. My hydrogens are already stable with 2, so I'm going to pick a carbon to fill its octet. So here's 8 total electrons, and here's 10 total electrons. So now this left carbon has a full octet, but this right carbon still does not have a full octet. But I am at that magic number 10. I can't draw any more lone pairs. When we do this, we take a lone pair and we share it again. And so I'm going to take this lone pair and I'm going to share it to make a double bond. So now my left carbon still has a full octet. My right carbon has 2, 4, 6 electrons around it. That's still not a full octet, so I'm just going to repeat that process. Take a lone pair and share it again to make a triple bond. Now each carbon has a full octet, and I have drawn 10 total valence electrons in my Lewis dot structure.